What's up, math fans? Today I want to solve quadratic equations by completing the square. So hopefully you've already seen the video on completing the square when it was just expressions, not equations. And you learned in order to complete the square you need to use b divided by 2 and then square. And I even explained that you get the b from something like this, ax squared plus bx plus c. This is considered a quadratic because the highest exponent is 2. Now the difference between that video and this video is we're going to use that skill to solve an equation, and in standard form the equation is generally equal to 0. Alright, so these are all equal to 0. If you see my old videos on solving quadratic equations, it doesn't have to equal 0 because you can use the inverse to make it equal to 0. So don't worry if it's not, but these are. Also, completing the square is helpful because I'm comfortable with perfect square trinomials. When I see one, I know how to factor it. Okay? Now, let's look at the first one. I'm going to try to complete the square, just like I did in my other video of completing the square. So what did I do is I need to think of a number that I can add to make this thing a perfect square trinomial. But then I also explained you can't just randomly add something to an expression or an equation. You have to keep the balance. So in order to keep it equal or not to change the value, whatever I add I have to immediately subtract, okay? And then I'll drop down the equal 0 right here. So b is what? 8. So if I'm doing b over 2 squared, that means I'm doing 8 over 2 squared, right? What is that? 4 squared, which is 16. This is the number that completes the square. So this is the number I put here and here. And why is this so helpful? Because now I'm looking at a perfect square trinomial, which is easy for me to factor. It's x plus 4 squared. Now my minus 16 is going to drop down, equals 0 drops down. Now I want to somehow get x alone. So let me get rid of that minus 16 first. Get rid of all that loose change, if you will. Put it to the other side. That cancels out. And x plus 4 squared equals 16. I still need to get x alone. It's not alone yet. There's actually a square there. How do you undo, reverse, or inverse something that's squared? The opposite would be taking the square root of both sides. The square root of something squared, that kind of cancels each other out because they're inverses. And whatever's inside drops down, comes outside. So x plus 4 comes outside. Now, something else you should know. The square root of something is not just the positive answer. It could also be negative. If I asked you for the square root of 16, it's really the positive or negative square root of 16. Because what's the square root of 16? 4, but it could also be negative 4, because negative 4 times negative 4 is still positive 16. So to give yourself a hint or to remind yourself, you're looking for both answers, positive and negative square root of 16. But how could you put two answers at the same time? You can't. So you have to split it up. Here's what I mean. X plus 4 comes outside equals whatever the square root of 16 is, which is 4. But wait a minute, it could also be negative 4. So give me a second equation. Or x plus 4 could equal negative 4. Give me two equations. And you kind of knew that because quadratics, we already discussed, quadratics generally have two solutions. So let's solve the first one. Inverse here, x equals 4 minus 4 is 0, and that's okay. X is 0. Plug it in, 0 squared plus 8 times 0, that's 0. So you know it works, you're good. Here, minus 4 on both sides, x equals negative 4, that's okay too. I'm sorry, negative 8. How did I know that? Because I just mentally checked myself. Okay, negative 8, and that's okay too. So two solutions. This is the easiest example I could think of for completing the square with equations. Here's slightly more complicated. Look at this trinomial. Try to solve. The old school way of solving is to use the sum product method and then the t-chart. But I don't know the factors of 51. Although you could do it. You can easily do this using sum product. But me, myself, I don't know the factors of 51. I'm confused already. So I'm going to go with completing the square method. So I'm going to actually ignore the 51. Move it out of the way. Some people teach it where they bring the 51 to the other side, which is fine. They add 51 to both sides, and that's fine. When the 51 is out of the way, we focus on the x squared plus 14x plus something minus something immediately, and then the 51's hanging out on the other side. So I'm actually going to leave the 51 here equals 0. But you can do it where you add 51 to the other side right away. I'm going to let it hang out though. I don't want it to be lonely. What number goes here? 14 divided by 2 is 7. 7 squared. 49 completes the square. It's a perfect square. Now this thing is exactly what I wanted. A perfect square trinomial. What is it? X plus 7 squared. Minus 51, I'm sorry, minus 49 now has to drop down. And minus 51 has to drop down. And that is equal to 0. What am I going to do? If you added 51 earlier, now you would add 49 and bring them both to the other side. But I am going to combine like terms. So I have x plus 7 squared minus 100 equals 0. I want to get x alone. What did I do before? Get rid of that loose change. I'm going to add 100 to both sides. And what do you get? I'm going to actually bring it up there. I need some space. So I have x plus 7 squared. This is gone. Equals 0 plus 100 is 100. Equals 100. Okay? Don't get confused. Number 1 is done. Now what? How do I get x alone? I got to reverse, undo, inverse this square thing. Take the square root. Both sides. Don't forget I want the positive and negative square root of 100. So what happens? Cancels. X plus 7 drops down. Equals what? 100 square root is 10, or is it negative 10? I don't know. Let's go with both. So I'm going to say either 10 or x plus 7 equals negative 10. Two equations, two solutions. Minus 10, I'm sorry, minus 7. So x equals 10 minus 7 is 3. Or subtract 7 here, and x equals negative 10 minus 7 is negative 17. And there are my two solutions. All right? By the way, if you use some product, you would have got the same answer. Here is a much more challenging one. Can you use some product here? I don't think so. So right away I have to use, actually there's a couple different options. There are other videos for that. But in this option, I have to use the completing the square method. So x squared minus 12x plus something minus that same something, right? Plus 23 equals 0. Lucky for me, that's an even number, so it's easy. 12 divided by 2, actually negative 12 divided by 2 is negative 6. Squared is still positive 36. So plus 36, immediately subtract 36. And I'm going to combine these two. What is negative 36 plus 23? I believe that is a negative 13, right? Check my work. Don't just take my word for it. Do the work. All right, but this thing, what is it? Perfect square trinomial. X, this time it's minus 6 squared minus 13 equals 0. I really think you got it from here, but stick with me if you want to see what happens. Add 13. X minus 6 squared equals 13. Take the square root. Ah, look at that. Is 13 a perfect square? No. So what do? Panic? No, just leave it like that. So, cancel, cancel. Either x minus 6 equals radical 13, which is fine, or x minus 6 equals negative radical 13. Notice the negative is on the outside. Okay? Let me add 6. X equals 6 plus radical 13, or radical 13 plus 6, however you want. But more common, you'll see it like this. 6 plus radical 13. Or, what's this? X equals 6 minus radical 13. So you have, again, two solutions. This is considered simplest radical form, or the exact value, rather than running to your calculator and getting some crazy decimal and then rounding it. So this is exact value. Okay, thanks for watching. See ya.